Hello everyone and welcome back to the PICO Developer channel. With PICO S6, we are stepping into the next generation of spatial computing. Today we are looking at shared space. Unlike full space mode, which takes over the entire headset for a single immersive experience, shared space allows your application to run side by side with others. By leveraging our unified rendering, your applications can mix 2D interfaces, 3D models, and users' real-world environment all at once. To show you exactly how this works in practice, I have developed a game called Naval Strike. In today's tutorial, we will be using this project to demonstrate step by step how to develop a shared space game by using PICO Unity Spatial Adapter. So let's switch over to my screen and dive into this Unity project. Okay, let's dive into our demo project, Naval Strike. Naval Strike takes the classic pen and paper fleet destruction game and brings it into a shared spatial environment. In this demo, the player plays against an AI opponent. As you can see, there are two boards set up opposite each other in the space. On your command board, you have two distinct 10 by 10 grids. The first is used for placing your own fleet, while the second is your tactical map for tracking your shots against the AI. We have also added a tactile control panel. You simply use these four directional arrow buttons to dial in your target coordinates on the grid and then hit the fire button to launch your missile. So now let's have a look at the package manager. I want to show you which packages I imported into this project. Here you see we have PICO XR SDK imported. The version is 0.11.0. And there are some other packages included. These are also a part of the PICO XR SDK package. You don't need to manually import them. I will show you how we import them by using the PICO portal. PICO portal also shows up automatically as soon as you import the PICO XR SDK package. Based on the project you're aiming to develop, you can choose between PICO XR or PICO Spatial. PICO XR is just for developing standard XR applications, and PICO Spatial is for developing spatial applications, including full space and shared space applications. And Naval Strike is a shared space application, so we choose PICO Spatial option here. And here you can see all the required steps are completed. And the additional packages we have seen on the package manager are added by using this window. If you're wondering how to access and download the latest SDK packages, you can go to PICO Developer website, and under the resources link, you can find the Unity, not just Unity, also other supported platform SDKs. And the one you need to download is tagged with OS 6 preview. You can just go here and download the latest version and also access the documents and samples. On the same resources page, you can also find a link to the PICO Emulator documentation. To test this project, we are going to use PICO Emulator. You can find the installation steps on this page. Please follow the instructions to install the latest emulator version. So once the PICO Emulator is installed, now you can create an empty spatial project, then go to the device manager to add a new PICO emulator, and then you can just press play button to start the emulator. Before we start exploring the SDK features, I would like to show you how we can run a build on the PICO emulator. Okay, let's open the build settings to generate an APK file. When the build is started, the spatial adapter will do some changes on the scene, and then in order to save those changes, you will be prompted to save the scene during the build process. And the APK is ready. Let's run the emulator once again. And to install the APK, we just drag and drop the APK into the emulator window. Okay, good. The game is installed. Let's now give it a quick try. We don't have to get a build every time we want to try or test something about our apps or games. We can use Play to PICO feature. So let me show you how it works. First, we need to install the Play to PICO server APK into the emulator. You can find this APK file inside the PICO SDK package. Just go to the Spatial Adapter folder, then Spatial Adapter Runtime, Server, and then here is the APK. Just drag and drop to install. And let's run this server APK. Okay, the server application is running and ready. Now we need to configure our project to connect to this IP address. Let's open the project settings and go to PICO Spatial section. We simply need to enter the IP address into this host server IP address field here. Okay, now we are ready to test Play to PICO feature. Let's press play on the Unity editor. If you encounter a warning like this, you can resolve this problem by going to the macOS settings, then privacy. Don't click move to trash, just click done. And then under the security panel, just click allow anyway. You might have to repeat this once more. Nice, now Play to device is functioning. Unity editor is running and we can see the game being rendered inside the PICO emulator too. Let me also arrange my windows so that we can see Unity editor and the emulator side by side. Let's also have a very quick test run. Okay, this looks good. Now that we have the emulator and Play to PICO set up, let's look under the hood of the Naval Strike project. If you are building a spatial title, standard cameras simply won't work. Instead, we are using a spatial camera. This is a core component provided by the PICO Spatial Adapter. What this camera does is specify a rectangular volume of your Unity scene that will actually be visible to the user in their shared space. You can resize this volume by changing the dimensions on the spatial camera. To control how your project renders inside that volume, the spatial camera can exist in one of the two modes, constrained or unconstrained. If you select constrained, boundary constraints are applied, the display will be cropped, and your Unity scene will only appear within that specific rectangular volume. If you select unconstrained, there are no boundary restrictions. The view will not be cropped and the entire Unity scene will be displayed to the user. Next, let's talk about input. For this project, we are using the standard Unity XRI toolkit to handle our interactions. The ships and the buttons on the board are all interactable objects. As you can see here, we added the XR Simple Interactable component to our buttons, while the ships use the XR Grab Interactable component, so they can be picked up and placed on the grid. To interact with these objects, we need an interactor. In our scene, we have a game object called Custom Spatial Interactor. Attached to this is a component called XR Spatial Pointer Interactor. This is actually a slightly modified version of the interactor that comes directly out of the box with the PICO Spatial Adapter SDK package. The only difference between my custom version and the original PICO interactor is that I added two public methods. These methods let us check whether the player's interaction is a pinch gesture or a touch interaction. I wanted the ships to be interacted with using pinch gestures only. To filter out any accidental touches and strictly enforce this pinch-only interaction, I created a custom XR Select filter and attached it to the XR Interaction Manager right here in the scene. Here we see that the Select filter simply checks whether it's a pinch interaction or not. If you look at the XR Grab Interactable component on any of our ship objects and expand the Interactable filter section, you can see our custom select filter is referenced right here as a starting select filter. This guarantees that the ships will only respond to when the user performs a pinch gesture. By default, the PICO Spatial Input System is configured to only interact with objects on the default and UI layers. But as you can see up here, we have placed our ship objects on a custom layer specifically called ship. If you leave it like this, our spatial pointer will completely ignore them. We need to explicitly tell the system that the ship layer is interactable. To do this, we open up the project settings and navigate down to the PICO Spatial section. Inside these settings, we look for the Spatial Adapter Collider Layer Mask. Then we simply add Ship Layer to the mask. Okay, now on to the next topic. If you want our meshes to cast and receive dynamic shadows when using the PICO Spatial Adapter, we need to use a specific component called the Spatial Adapter Grounding Shadow. You need to attach this component to an object with a mesh. There's a crucial detail to remember here. Currently, this grounding shadow component must be attached to both the meshes that you want to cast shadows, like our ships, as well as the meshes that you want to receive those shadows, like our game board. By applying it to both the casters and the receivers, your objects will blend much more naturally into the spatial environment. Okay, that wraps up our tutorial for developing shared space applications using PICO Spatial Adapter. Now I invite you to download and explore the complete project yourself. You can find the download link in the video description below. I have also linked the official PICO Developer documentation. I highly recommend checking out the section on the Unity features supported by the PICO Spatial Adapter so that you know exactly what features and tools are at your disposal for your own games and applications. Thank you so much for watching. I will see you in the next tutorial.